You can't see it. Let me get the sharing again. There we go. Good. But that's what it gives you, though. Okay. You know, pretty accurate and stuff. And if you instead, this is what happens if you left the minimum blank. If you instead left the maximum blank and put a bound in the minimum, I put 2 there again, you could see it's going to give you the area to the right of 2. And you'll get the actual area here. It'll give you this number. Like so. And of course, you can put numbers in between as something for the min, something for the max, as you can see. It'll give you the area, and it'll give you the number. So again, this is a little bit, I guess, more precise than the table. People still do work with z-scores. You know, people still do that. Okay? But just like, you know, you work with a calculator to do calculations, you know, arithmetic, that is, people still use Desmos to do these things. Are there any questions on this? Okay. So let's do another example. This is an older one actually, but we're going to solve it using Desmos. I'm going to type it in Desmos as well. It's with the test scores and stuff. You know, the test scores are out of 10. We have a normal distribution. The mean is 6, and the standard deviation is 0.3. Okay. We want to know what percentage of students scored between 5 and 5.5. I mean, we did actually do this before with z-scores. Now we're going to use this for Desmos. So what I'm going to do is I'm going to go to Desmos. Let me see. Can I see? Good. I'm going to share my Desmos screen. So let me stop sharing this. Here it comes. So we're in Desmos. Let me see if they can see it. Waiting for it to show up on your screen. There it comes. All right, we got that. Okay, so let me go to graph and calculator. Okay, so again, we had a normal distribution. So we can go to, I mean, you could type it in, but I have keyboard, functions, go to DIST. We have normal distribution. These are other distributions that we're not going to look at though. Okay, and we had, let's see, what was it? I think it was 6 if I remember correctly. Yes, it was 6. No. 6. Standard deviation was 0.3. You don't. Okay, I'm just going to move the graph so it's easier to see. I'm going to zoom in. See, we want CDF. Click that, and we want to go from 5 to 5.5. So you can see it's giving us the area. Let me zoom in even more. Okay, we have the area here from 5 to 5.5, as you can see. There we go. Okay, now this is the area. And this is the number it gives us, which is what that area is. Okay, now, okay, so we have the area. I mean, I actually rounded it off on the slides. So let me get back to the slides now. Okay. Good. I mean, I did round the number off, as you can see, which we get about 4.736%. I showed it in Desmos, so that's what we get here. Okay, so that's pretty good. I'm sure it's less work than finding a z-score. If I do want you to use a z-score on an exam, I will tell you that. Okay. Are there any questions on this? So here's that annual rainfall example again. This time I did it using Desmos. I got the scores and stuff. You can see they're probably a little bit more accurate than the table, I would imagine. But again, we're assuming the annual rainfall in a certain region it's normally distributed with this mean and this standard deviation. Okay. You know, it is a problem from the textbook. So here we want to know the percentage of years, okay, that will have an annual rainfall less than 30 inches, okay? What percentage of the years, or data values in this case? So again, what do? Well, for Desmos, you could type in, you know, that normal distribution stuff, 33.5, standard deviation 5.6. You know what? Let me do it. At first, I wasn't going to put in Desmos again, but I feel better doing that. So let me share the screen again. Window, no. Okay, so this is 33.5, 5.6. So I'm typing it in here. 33.5, 5.6. I mean, you can see we really, wait, no, that should be a comma. There we go. You can see we really can't see it, but let me see if I can scroll over. Actually, here, let me do it this way. Graph settings, right? Graph settings, you could change it. So we have 40 to 25. How about that? There we go. See? So now we want to go less than 30. So we leave minimum blank and we type in 30. Is the area to the left, and this is the number we get. Again, I sent you the notes, so you should have on the notes, you should see that the number is there. I mean, I did round it off, and we get that the percentage of years with an annual rainfall less than 30 inches, we get it's about 27.60%. Now, I did round it off and convert to a percent. You want to convert to a percent at the end. That's what's happening here. Okay. You know, so about 27.6% of the data values will have less than 30 inches. In other words, about 27.6% of the years in that, I guess of the years, excuse me, will have an annual rainfall less than 30 inches. So 40, it's the same idea, right? The only difference is that instead of 30 here, we have a 40. Get this number. And again, I'm not going to go back to the slide yet, but you should have the slide in front of you. 0.8771. I rounded it off. So the percentage of data values here, less than 40 inches, okay? You know, it's approximately 87.71%. Okay, and finally, between the two, the 40 we can leave, we type 30 here, and you get this number, which is pretty close to what we actually got, about a little more than 61%. All right. Okay, now let me go back to the slides. You know, we had this number and we rounded it, and then we convert to a percent. All right, let me get back to the slides. Here it comes. Okay. All right. Okay. I mean, it is in the textbook also, this example. I'm not sure if I misspoke with the interpretation, but I'll think about it more though. Okay. But does this make sense to everyone? I mean, the calculations we did were correct. So okay. Percentage of years. So okay. Well, here's another one, okay? Wait, let me see if they can see it. Okay, so this is another example that here you can just use it in Desmos, okay? Basically here, our data set, let's say the value's there, okay? It's normally distributed, all right? With a mean of 10 and standard deviation 3. I don't know what values the data set, you know, represents, but for now it doesn't matter. We want to find these. We're going to use Desmos. Let's find the percentage of that data values or values between 9 and 10. Values, data values, same thing. The percentage of values between 9 and 10. And we're going to find the percentage of values between 11 and 13. Okay, well, if you were to use Desmos, you type all this in, okay, this is what you would get. In fact, let me show you. Let me go back to Desmos. Okay, so the normal distribution is normally distributed, mean 10, standard deviation 3. Okay. Wait, let me get the 5 out of there. There we go. So I think they said between, so on the slide it says between 9 and 10, right? 9 and 10. Okay. If you press home here, it takes you back to the origin. Let me zoom in a bit, as you can see here. Okay. So between 9 and 10, that area, it's about this much, which is on the slide. Okay. And so as a percentage, you just basically move the decimal to the right 2 spaces. You get about 13.056%. I did round it off. On the final, of course, if this is on there, I'll tell you how many decimal places to round to. And on the slide, the next question, the second question, again, it's between 11 and 13. So let's do 11 and 13. Okay. So it does the calculation for us. We can see the graph also. This is what we get between 11 and 13. And so in this case, we get about 21.079%, approximately. Okay. Okay. Good, good. So let's do this again. Let's keep going. All right. All right, let me get back to the notes. I know I didn't share the notes in between, but again, I did email the notes to you, so you should have the notes in front of you. Okay. So here's another example. Okay. So here I actually say that you find these using z-scores. So that's what we have to use. We can use Desmos to check, I guess, if we want, but we have to use z-scores. Okay. Let me just pause the recording.